Okay, so last time we went over how logarithms and exponential functions are inverses of each other. And remember that if they are considered inverses of each other, that means that their bases have to match. So for example, this would be a case of a logarithm and exponential function that are inverses of each other. The bases are the same. They both are 2. Okay? After we covered that, we talked about how problems like log base 3 of 3 squared, we talked about how that would equal 2. And the reason that they do is because you've got a log and an exponential function. Their bases are both 3s. So since their bases were the same, we were able to cancel them, and we were left with a 2 for our answer. Okay? The issue is that when you guys do this, those last problems were set up so that your bases matched. Your bases will not always be set up so that we can easily see, hey, there's a 3 and a 3. So for example, you have a log base 5 of 25. We have a log base 5 of 25. I cannot cancel right now. I can't cancel anything because the 5 and the 25 do not match. So I've got to be able to rewrite these things. Okay? So when I do this, you're going to start out by showing this step. Since this is a base of 5 here for my logarithm, I know that I need this to be a 5 here so that they can cancel. Okay? So essentially what you're doing is I'm saying that I've got a log base 5 of 25, and I've got a log base 5 of 5 to some power. Okay? So they both have a log base 5. So basically our question that we're asking ourselves is, we're saying 25 equals 5 to what power? That's what we've got to figure out. So 5 to what power gives me 25? Some of you guys might be able to answer that right away. Some of you guys might not. This one you might be able to answer right away. Others might end up being more difficult. You will use your calculator. We're going to start plugging in. 5 to the first power. No, that's just a 5. 5 squared. 5 squared is 25. Okay, so that's what I need. Okay? So when I do this problem, I've got a log base 5. I know that the two 5s have to be the same. So my question is, 25 is the same as 5 to what power? Well, that's a 5 to the second power. Okay? So now, I've got their bases to match. So since their bases match, I can cancel, and I'm left with an answer of 2. Okay? So log base 5 of 25 equals, I can't cancel that there, so I've got to make their bases match. 25 is the same as 5 squared. Now that they match, I can say that my answer is 2. Okay? Another one. Let's say I asked you guys log base 2 of 8. Okay? Log base 2 of 8. The whole point of this is their bases have to match. So we have to get their bases to match. Okay? So if I look down here, this has a base of 2, which means when I rewrite this, I'm going to have a log base 2, and I know that that number has to be a 2. I know that that number has to be a 2. Okay? So what's the relationship between 8 and 2 to some power? Okay, again, if you don't know it right off the top of your head, just start with your calculator. 2 to the first power. No, that's 2. 2 squared. No, that's 4. 2 cubed, or 2 to the third power. 2 to the third power would give me 8. Okay, so that's a 3 in there. I'm checking to make sure 8 is the same as 2 to what power? Now that their bases match, I can cancel, and I'm left with a 3 for my answer. Okay? So those are kind of the simple ones. Now I'm going to show you guys there's 3 different examples that can be a little bit more difficult. The first one I have is I have a log base 2 of 1/2. Log base 2 of 1/2. The nice thing is that our rule is the exact same. I've got to be able to cancel. So I need their bases to match. Okay? So I need a 2 here, and I've got to have a 2 in that part in parentheses. Some people will say, oh, there is a 2 there. But that's not just a 2. Okay, it's got to be just a 2. It cannot be a 1/2. That 2 cannot be on the bottom. So my first step is to rewrite this so that their bases match. Log base 2 of 2 to some power. Okay? So 1/2, how is that the same as 2 to some power? Well, our issue is that somehow this 2 got on the bottom of the fraction. So what type of exponents do we use to get the 2's, or to get numbers to the bottom of fractions? Or what kind of exponents do we use to cause things to flip? Well, if you look back when we were doing lesson 4.1, say I had something like this. Remember, if we saw negative exponents cause them to move to the bottom. Okay? So what kind of exponents are going to make this 2 get to the bottom? They are going to be negative. Okay? So since that 2 is on the bottom, I know that I've got a negative. And I know that I'm going to have a negative 1. Okay? 2 to the negative first power. Negative exponents make it move to the bottom. I end up with 1 over 2 to the first power, which is just a 1/2. So negative 1 is the exponent that I am going to plug in. Whoops. So negative 1 is my exponent that I'm going to plug in. Okay? Now that my bases match, 2 and 2, our bases match, I can cancel those, and my answer is negative 1. Log base 2 of 1/2 is negative 1. Okay? So our note for this is if you see fractions show up in the parentheses, we're going to use negative exponents. If you see fractions show up, and this is important, I'm showing you guys each one of these examples. Fractions show up, we're using negative exponents. Okay? Next, what about if we have square roots that are involved? Okay? Again, my goal is I've got to get their bases to match. So I'm going to rewrite this first. Log base 6 of, I know that I have to have a 6 there. And it's a 6 to some power. Okay? So log base 6 of square root of 6 equals log base 6 of 6 to some power. So the square root of 6 equals 6 to what power? What goes in there? Okay? For this one, you guys should be remembering our jam rule. Jam. And remember that picture of Mr. Sheever dunking the basketball? And then Jaron Richmond was down there. Okay, so remember, when we use our jam, it's a to the m over j power. A to the m over j power. Okay? So, if I'm dealing with a square root of 6, remember we don't write the 1 in there, so my m is a 1, so the top part of this is going to be a 1. And then the bottom, okay, it's a square root, they don't write it, but there's a 2 out there, so the 2 and the j are in the same spot, so the bottom is going to be a 2. So the square root of 6 is the same thing as 6 to the 1/2 power. So you want to remember your jam rule when you are dealing with radicals. Okay? Now that I've got that figured out, base of 6. This is going to give me then, wow. Oh, wow, I wrote the 2 like that. Bases match, we can cancel, and I get 1/2 for my answer. So log base 6, the square root of 6, that equals 1/2. Okay? So for this one, I've got radicals. Radical is just another word for root. When you see a radical, you're thinking fractions. And specifically for my fractions, I'm going to be thinking my jam rule. Okay? Next one. I've got a fraction in the base now. Okay? Doesn't matter if I have a fraction in the base. Rule is still the same. I've got to make this a 1/3 to some power. 1/3 to some power. Okay? Now, first, if you see fractions, what should we be thinking? If we see fractions, we should be thinking negative exponents. Oh my goodness, I did not mean to grab that. Okay, we should be thinking negative exponents. Okay, just because I have fractions in the base doesn't matter. Okay, I'm still thinking negative. I've got 9 is the same as 1/3 to what power? Okay, well somehow that 3 got up to the top. So how did that 3 get up to the top? Well, that's where our negative exponents come into play. So I know that this is going to be negative. Okay? The next question is, how did that 3 become a 9? How did that 3 become a 9? Well, that would have to be a 3 squared to become a 9. Okay? So I've got a negative 2 there. Now, just showing you guys that that does work. How does that work? Okay? If I take 1/3 to the negative 2, that negative 2 has to go to both of those. So that's a 1 to the negative 2 over a 3 to the negative 2. When I do that, those negatives make them flip. So it's a 3 squared over 1 squared. 3 squared is 9. 1 squared is 1. That's how I end up with a 9 for my answer there. Okay? So, log base 1/3 of 1/3. Okay? In order to get that to be a 9, this has to be to the negative 2 power. Their bases are both 1/3, so we can cancel. Our answer is just a negative 2. There's one last special case that we need to cover. And I've got log base a of 1 equals 0. The reason that I put an a there is that a represents any base. It does not matter what the base is, that equals 0. This all stems from our rule for exponential functions. Remember, our rule for exponential functions is anything to the 0 power gives me 1. Remember, your exponential functions and logarithms are inverses of each other, and since they're inverses, it's all a whole lot of switching. So now it's the backwards way for a log. Log of any base of 1 has to equal 0. And if you think about it with our rules, that makes sense. Okay, log base 2 of 1. Our rule is I have to rewrite that as a log base 2 of 2 to some power. Well, 2 to what power gives me a 1? Any base to the 0 power gives me 1. So that means that I'm going to plug a 0 in here. So when I cancel my 2's, all I'm left with is a 0. Same thing here, log base 6. I've got to rewrite that as 6 to some power. Well, 6 to what power gives me 1? Anything to the 0 power gives me 1. So what's going to go in here? Well, it's going to be my zeros. I can cancel those because they have the same bases. Log base 6 of 1 equals 0. Okay? So this is just a general rule. You could show this step. I think showing this step shows your understanding, but you don't have to. You can also just remember, okay, log base 5 of 1. Well, I know that log of any base automatically equals 0. Okay, so you don't have to show work on that. Now, threw a lot at you guys there. In class, we'll have this simplifying logarithms worksheet that we're going to do. We are also going to do a lot of practice problems together before I even give you guys that worksheet. Okay, so remember, we're still going to have plenty of time to work on these. I know I threw a lot at you. It's the first time you guys have seen this, but we will have a lot of practice that we will do next time in class.